Existential import of categorical proposition. What we need to note first is that all the relationship that we have been discussing so far actually have assumption that what all categorical proposition have members. That is, there is nothing like empty class in the standard form categorical proposition. Like, it actually assumes that what both A, E, I, and O proposition have members in their classes that are in that particular what proposition. But the modern logician have already rejected that what it is possible to have an empty class. For instance, if I say there are no witches, what this particular proposition is talking about is that this class of witches is what? Empty. That is, it does not exist. Like, there are no members in this particular class. But in standard form categorical proposition and their relationship, it actually assumes that what all the classes in those propositions actually have members. But the modern logician have actually argued that what it is possible for us to have a class without any members. So when we talk of existential import of categorical proposition, a particular proposition have existential import if it actually affirms the member of the classes in that particular proposition. So modern logicians are now saying that the universal proposition, both A and E proposition, A and E, does not have what? Existential import. It does not have existential import. What they are saying is that what the A and E proposition does not affirm the existence of any members of the class in that particular proposition. Let me say, for instance, A proposition: all students are learners. So what the modern logicians are saying is that this statement, all students are learners, does not affirm that what there are any students, and it does not also affirm there are any learners. What the statement is just saying is that if there's any student at all, then it will be a learner. All students are learner. This statement is not telling us whether students exist or learner exist. It's only telling us that what all students are learner. That is, if there's any student at all, then it will be it will be a learner. All students are learners. In a similar way, if I say all dogs are animals, so the modern logicians are saying that what this particular A proposition, it does not affirm the existence of the members of this either dogs or animal. It's only telling us that if there is a dog at all, then it will be a animal. Then also no men, E proposition, no men are women. What this proposition is saying, according to the modern logician, is that it's only telling us that if there is any men at all, then it will not be a woman. So it is possible for us not to even have men or not to even have women. But what the statement is saying is that if there's any men at all, then it will not be women. No men are women. So it does not have existential import because it does not affirm the existence of the members of that particular class in the proposition. So for the modern logician, both A and I proposition does not have existential imports. But they claim that the particular proposition, whether I and O, actually have existential imports. That is, it actually affirms the existence of the members in that particular classes or in those particular classes. Let's say we have the proposition: some students are learners. So what they are saying is that this particular statement, I proposition, it actually affirms that students are existing and some of them are learner. Some students are learners. From there we can actually see that there are some group of people that are called students and they are also learners. Some students are learners. Some boys are drivers. It's telling us that boys are existing and some of them are drivers. But the A proposition, all boys are drivers, it does not affirm the existence of any boy. It's just telling us that if there's any boy at all, then it will be a driver. All boys are driver. It's not indicating any particular boy. It's not talking about the existence of the boys at all. It's just saying that all boys are learner. That is, if there's anything that is a boy at all, then it will be a driver. So that's why they say this one does not have existential import. The A proposition does not have existential import. but I proposition do have existential what import. Some students are what learners, some boys are drivers. So this particular proposition are indicated that what this particular class, their members are what existing. There is a member in this particular class. It is not equal 0. That is this particular class of student, though it is not equals what 0. It is actually existing. Sure, you understand? That is, some students are learners. It's indicated that what we have a group of people that existing that are called students, and they are also what learners. So that is I proposition. Then also O proposition. Let's say for instance we have some girls are not lesbian. What this particular proposition is also saying is that we have some people that are called girl, or we have some group of people that are called what girls, and they are not what lesbian. So both O and I proposition have existential import, but A and E proposition does not have what existential import. So the universal proposition, the standard form categorical propositions, have the existential import, while the particular propositions in standard form categorical proposition does not have what existential import. So now let's now go to diagram of representing proposition and their what relationship. Let's talk about the let's say we have a class of students, for instance, and we use this circle to represent a class of what students. So this circle is representing a class of what students. If there are no students, that is, students are not existing, that class is empty. Students. If the class is empty, that is, there are no students, all we just have to do is to what shade them off. So by shading them, it actually shows that what this class is what empty, that is, there are no students. There are no students. So to indicate that this particular class of students is what is empty, all we just have to do is to what shade them off. But to indicate that there is at least one student, that is, that class is not empty, there is at least one student, we put X. So if there are no students, that is, students, the class of students is empty, we are going to what shade them off. Then, but if there's at least one student, that is, they are students, all you just have to do is to write what X. And you know that standard form categorical proposition is affirming relationship between two different classes, not just one class. Sure, you understand? So let's say we have the class of students and we also have the class of what learners. Because in standard form categorical proposition, we are talking about the relationship between two different what classes. So how do we diagram that? So let's draw one circle. This is the circle of what students, and this is the circle of what learners. Because in standard form categorical proposition, we are talking about the relationship between the two of them, so that's why we overlap it on each other. So this particular circle now, it has 4 different spaces. It has 4 different spaces. Number 1, this space that you are seeing here, it is for students that are not what learners. Okay, let me just write XL, students, learner, students, learner. So this particular space now, it has 4 different circles. It has the circle, it has 4 different spaces. It has the space of students, people that are students, just this place. So people that are students but they are not learner. Then this is where student and learner comes together. So this space is for people that are students and they are also what learner. Why this space is for this space from here like this? It's for people that are learner but they are not students. Why outside the two of them is for people that are not both students and they are not what learner. So let me introduce the concept of bar. This is what I call bar. It is used to represent not or none. Sure, you understand? None. So if this space like this now, this space is for students that are not learner, so we are going to write X bar L. That is students, people that are students but they are not learner. This is their space. in this relationship. People that are students, they are not learner. Students are non-learner. But we are not going to bar anything here, because this space is for both people that are students and they are also what? Learner. Then this space is for learners that are not students, like this space like this. You see that their circle did not even intercede this place. So this circle students, this is where it stopped. So this space is going to be for learners that are not what? Students. So we are going to bar the X. Then outside is for people that are not learner and they are also not what? Students. So where are we going to bar the two of them? So as you can see now, the first space is for students that are not what? Learner. The middle space is for people that are both students, that is this space like this. It's for people that are both students and they are also what? Learners. While this space is for learners that are not what? Students. That's why I buy it. Then the outside is for people that are not learner and they are also not students. So let's quickly symbolize this now, then we move on to diagram their relationship. So let's say all students are learners. Oh, this is taking too much space. A proposition: all students are learner. So the symbol is going to be all students are learners. So students that are not learner equals 0. That is, all students are learner. If all students are learner, that means this particular place is empty. It is equals 0, because students that are non-learners is what? Equals 0. That's what I wrote. All students are learners. So students that are non-learner equals what? 0, because all students are learner. So if there is any student that is existing at all, it will be the one that is what? A learner, because all students are learner. So students that are not learner is what? Equals 0. Then the E proposition: no students are learner. So it will be students that are learner equals 0. That's the symbol. No students are learner. Students that are learner equals 0, because there is no students that are learner. So any student that is learner equals 0. That actually shows that this space, particular space, is also empty. No students are learner. So students that are learner equals what? 0. The first one, all students are learner. So students that are not learner equals 0, because all students are what? Learner. So students that are not learner equals 0, because any student that exists at all must be a what? Learner. All students are learner. Then this one, no students are learners. So students that are learner is equals what? 0, because there is no student at all that is a learner. So students that are learner equals what? 0. But this one says all students are learner. So students that are non-learner equals 0. So this place, no students are learner. So students that are learner. This one is students that are non-learner. This one is students that are what? Learner equals 0. Then the I proposition, how do we symbolize? Some students are learners. So that means students that are learner. There's no not in this one. No. Some students are learner. So students that are learner is not equal 0. Students that are learners is not equal what? 0. Then the last one, O proposition, some students are not learner. So some students are not learner. As you can see, there is not there. So students that are not learner is not equal 0. So some students are not learner. That means we have some students that are existing and they are not learner. So that means it is actually not equals what? 0. Students that are not learner is not equal 0. Some students are learners. Students that are learners is not what? Equal 0. Some, because we have some students that are learner. So students that are learner is not equal 0. But yes, students that are, some students are not learner. So as well, students that are not learner or students that are non-learner is not equal what? 0. Don't forget that when we talk of existential imports, we said universal proposition like A and E proposition does not have existential what? Import. That means it is possible for the class to be what? To be empty. It does not affirm the members of all those classes. That's why they are equal what? 0. But I proposition, particular proposition actually have existential import, so it is not empty. That is why they are not equal what? 0. So this one, all students are learner. So students that are not learner equals 0 because all students are what? Learner. Then E proposition, no students are learner. That student that are learner equals what? 0, since no student at all is a learner. Then some students are learner. So student that are learner is not equal 0. That means there is at least one student that is a learner. Then O proposition, some students are not learner. So that means students that are not learner is not also equal 0. There is at least one student that is not a what? Learner. So it is not equal 0. So having the knowledge of this symbolization, let's now go to how to diagram relationship between two different classes. So how to diagram A proposition, E proposition, I proposition, and what? O proposition. So let's say we are talking about the class of students and learners. So how many relationships can they have? 4. They can have all students can be learner, no student can be learner, some students are learner, and some students are not what? Learners. So let's say we have the number one, what's it called? The number one relationship, A proposition. All students are learners. So how do you diagram it? So this is the space of students, and this is the space of learners. All students are what? Learners. So what you will do is that look for the space of students that are not learner. We said is equal what? 0, because all students are learner. So in that diagram that I showed you the other time, where is the space for students that are not learner? Here. This is the space of students that are not learner. So you shade it up that this space is what? Empty. All students are what? Learners. So students that are non-learner, the space of students that are non-learner, you shade this that what? It is empty, because any student that exists at all must be the one that is a what? Learner. All students are learner. So this is the space of the one that we have people that is not empty, that is all students are what? Learner. This is the place of students that are what? Learner. Then this is the space of students that are not learner. We said that place is what? Is empty. That is why I shaded it off. Don't forget that when I drew the diagram in the first place, I said if it is empty, you shade it off. But if there's at least one, you put your X. So to diagram all students are learner, you just have to shade off the space of students that are not what? Learner, because it is equal 0. It does not exist. Students that are not, although you don't have to write this though. A proposition. No students are learners. Students, learners. So no students are what? Learners. So where is the space of students that are learner? We said it is empty because no student at all are learner. So it is in the middle. No students are learner. So you look for where student and learner are coming together. Then you shade it off to indicate that what? It is empty. Because no students are learners. So you shade it off to indicate that what? It is empty. Then the I proposition. Some students are learners. So the space of students, the space of learner. Some students are learners. So where student and learner comes together, here, then we say that there are some people there. Don't forget that there are some. If there is at least one, which is some, you write X. So some students are learners. So where student and learner are coming together, we said there are some people there. So you put your words X. So let's write O proposition. Some O proposition. Some students are not learner. This is space of student, this is space of learner. So we said some students are not learner. If you ask me that where am I going to put my X, I know a lot of people are going to say yeah, but it is wrong. They are going to put it here. Because the statement states that what? Some students are not learner. So that means this is the space of students that are not learner. Some students are not learner. So the space of students that are not learner, we said there are some people there. So you put your words X. That is all. So ladies and gentlemen, in our next video we are going to be talking about the logic of syllogism and Venn diagram for testing the validity of what, of syllogism, before we now move on to so right and empty means. So what I've just done so far is that what I use different Venn diagrams to represent different relationship between two different classes, that is standard form categorical proposition, whether A proposition, E proposition, I proposition, and what, O proposition. I said whenever you are diagramming, if you have anywhere that is empty, you shade it off. But if there's anywhere that is not empty, that is there is at least one, you use your what, X. All students are learners, so I look for the space of students that are not what, learner, and I shaded it off to show that it is empty, because all students are what, learner. No students are learners. I look for the space where students and learners are coming together. I said that place is empty, that is no student at all are learners, so I shaded it what, I shaded it off. Then some students are learners. Where students and learners are coming together, I said that some people are there, that is there is at least one, so I put my X. Some students are what, learners. Then the last one, some students are not learners. I look for where we have students that they are not what, learner, and I put my X there to indicate that what, some people are there, some students are not learner. So see you in our next video. Thank you.